A very good morning. Sorry, I was a bit, I think, over enthusiastic. So it's 11:55, so I can say a very good morning, and this is Alok Srivastava from Network Nuts. And coming back again after a long time, there is are no excuses for that. So, coming up with a very interesting video on LVM. Yeah, I know you know LVM, but please don't just stop the video and invest your time and see the whole video. I'm definitely sure you're going to learn some new things. Those are not taught in your RSC level or any other level. So, let us start with the basics of LVM. So I can just start down my magical gedit for you so that I'll be able to write a couple of notes for you. So I can jot down the notes here so that it will be easier for you to LVM. Let me make the font much more bigger. Not happy with the font. Font and color, I like cobalt. Change the size, make it to bold. Where is the mouse? Sometimes mouse really behave in a wicked manner. Much better. Okay, so deep into LVM. This is what the video is all about. Let us learn more about LVM. So I'm just starting off with the very basic fundamentals of LVM. I know that you have learned about LVM during your RSC training and your certification and other training courses, whether it is related to Red Hat or not. So if I start with the basic things, that we know that LVM stands for Logical Volume Manager or the management, and volume management, it create actually an abstraction layer. I can key points I can write down here. Number one, volume management creates a layer of abstraction. You have learned this in your RSC. Let me make it slightly bigger. Layer of abstraction over the physical storage. Number two, it provides much greater flexibility than using the direct physical storage. As we can combine the multiple hard disks or the partitions, I can reduce the size, I can increase the size. Those things are not available when you use the physical storage directly, and you are not restricted to a single hard disk. You are not restricted to a physical disk. These are the key points, and some of the advantages of using the LVM is that it gives you flexible capacity, and obviously it gives you resizable storage, which is not there in the static partitions storage. Number three can be your data relocation, though it is not a part of this video, but yes, the feature is there. And easy device naming. So these are some of the basic advantages of using the LVM. So let us do a start with the very basic things. One thing that you should remember while creating the LVM, so I already have the partitions created. Those are being labeled for the LVM. So if I give a fdisk-l command here, you can see I've got SDA 7, 8, 9, 10. They are all being created, but they are not converted into any physical volumes. So it is from where I intend to start. Okay, so the one thing that you should note or you should remember, that all LVM commands accept a -v argument. This is what we have not been told. or being mentioned in the books in your standard training curriculums. All LVM command except a -v argument which can be entered, it is solely up to you, even multiple times. I'll show you multiple times to increase the output verbosity. So you should remember, and always remember, that help is available on all LVM commands, and the syntax is very simple. It is command name -f help. So if you are planning to take the help of, say, on lv create command, so it can be lv create -f help, very simple, or man help is always there. So a good administrator should be efficient in taking the help very fast. Okay, so first command, what I'm going to show you is, I've got certain partitions. If I give a fds-l, these partitions are coming up, SDA7 and SDA8 and 9 and 10. They are being labeled as the Linux LVM, but I had got no partition or any physical storage right now. So 7, 8, 9, 10 are my target partitions. Okay, in your training you normally give this command, pv create dev SDA. Fair enough, it has created you the LVM, but why not increase the verbosity? Just give a -v. Look, it gives you much more information, wiping up the cache, setting up the physical storage with how many sectors available, zeroing the start devices, writing the physical volume, and then it gives you. You want more? Okay, I can do one thing, and anytime you can remove it. PV remove dev SDA, so means the capability is removed. It is not being, or not a physical volume now. So if I increase the verbosity, say 4 times V, like this, it is solely up to you. It gives me much more information, galore of information, the metadata and all the things, what happened when actually you had given this command. So it tells me I had started processing this command. The locking type is the local lock. It is not a clustered LVM. The SLinux context has been set, and it has checked the context from where lock LVM. LVM lock type has been set. All these commands has been what actually happens behind the scene. So once it is done, if I give a PVS, it gives me, yes, one physical volume is there. So I can repeat the same task for, say, pv create -v dev SDA8, right? So I've got two physical volumes here. 2 physical volumes are available here, and there is one very beautiful command, LVM disk scan. If any time, okay, I should write it down as it is certainly a new thing. Anytime you can see all block devices that may be used as a physical volume using the command LVM disk scan. Let me show you. It's a very beautiful command. If I go back here, if I give, say, LVM disk scan, it tells me how many devices. These are all the devices. I am not using any filter here, so by default it shows me all the devices. So it clearly tells me that only SDA7 and 8 are capable of, or are being may be used as the physical volumes, though 9 and 10 are also the LVM, but I had not issued pv create command on them. And you can see here 2 physical volumes. So by LVM disk scan command, you can find out how many partitions or devices can be used as the physical volume. It may or may not be a part of the VG or LV, but yes, the capability of the physical volume is there with the file system, right? Okay, that's great. And I had already told you, you can remove the physical volume anytime. Say I give here PV remove, say dev SDA8, done. So if I give LVM disk scan, it merely gives me one volume. Fair enough. So I again give this because I need at least two. So I give a PV create -VV and dev SDA8. So here I increase the verbosity, so it is giving me a lot of information, a very useful information. So if I give a PVS now, yes, it is showing me how many physical volumes are there with me, right? Okay, now what? Once the physical volume is there, I need to combine them into the volume group. I know you have learned all these things, but just because of the sake of the continuity, we need to follow these steps. I'm sorry for the repetitive lecture, but you need to go with this. So I give a very simple command, vg create, say any name, say vg1, and then choose how many physical volumes should be participating in this. So I give SDA8 and 9. Wow. And if you want to increase the verbosity, let me remove it first. VG remove VG1. I had removed it, I had given the same command now, and I had increased the verbosity. See, so it gives me an insight of what is happening, right? So if I give a the PVS command now, it tells me that both the physical volumes are the part of the VG1, and if I give a VGS, it gives me the information related to the volume group. And anytime you can give VGS-V verbose, so it also gives you a lot of information, like the volume 1, the attribute is read, write, 4 MB is the size of the extent, 2 physical volumes are there, no LV is there, total size, how many free extents, and the UUID allotted to this volume group. In the same manner, you can also give PVS-V. See, so it gives you a lot of information, very good and a very important in case you are working on some production environment servers and you fix, or you are say doing some troubleshooting or trying to come out of a situation, then it can be very helpful. Okay, and other commands are PV display, obviously, and you then -V can be attached here. Okay, now I have got, if I give a PVS, I have got 2 physical volumes and I have got 1 VG, and both the volumes are the part of the VG. So I create one more, PV create, say dev SDA 9. So it is again successfully created. So if you see there, SDA 9 is not a part of the VG. So anytime you want to extend the VG, it's very simple, VG extend, and then the name of the VG, VG1, and then the device you wish to add into it, SDA 9, successfully extended. So if I give a PVS now, you can see here, all the physical volumes are the part of the VG, and if I give a VGS now, it clearly tells me it has got 3 physical volume, and the size is correspondingly increased by approximately 1.4 GB, right? Okay, and you should always remember that you can use the VG scan command and the LV scan command to check. I can say VG scan, so it is checking all the physical volumes and found one volume group. By default, whenever you start the machine, the operating system or the kernel automatically runs the VG scan command, so that the kernel will be able to update itself how many volume groups are there, right? And anytime you wish to remove a volume group, or you want to remove a PV actually, so if I give a PVS here now I want to remove the SDA 9, so I can give VG reduce and then the VG1 and then the volume group you wish to remove it, SDA 9. So again it goes back to 2 physical volumes. So one volume has been removed. That is good. That is good. Okay, I can remove a VG altogether. If there is no LV in it, I can remove a VG. If I give a VGS and I don't have a LV. So what I can do a VG remove and say VG1. So the whole volume group is removed. But make sure that there should be no LV and there should be no data. Right? Okay. You can also split a VG. It is very interesting. Splitting a VG. Let me write it here. Split a VG, volume group. It's very interesting. There's a very good command, VG split. VG split, and then the name of the original VG. Say original VG, then new, then split VG, and then which device you wish to split. Very simple. Let me show you. Suppose now if I have got a VG here, I don't have a VG. Okay, I create a VG here. VG create, say VG1 from devices SDA 7, 8 and 9. So if I give a VGS command, I've got a volume group here that contains these 3 physical volumes. For some reasons, I want to create one more VG which should be occupying this physical volume. So means I need to split this VG and take this chunk out, or the partition or the physical volume out, and put it in a separate VG. So the command is very simple, VG split VG1, and I give the name of say split VG, and then the physical volume you wish to split SDA9. So it tells me new volume group split VG successfully split from the VG1. So if I give the command PVS, see here, this is now a part of our new VG, split VG, which is automatically created using dev SDA9. So in this manner you can split the VGs, right? I can combine the VGs also. VG merge. I don't want this. I want both should be merged into a single one. Right now I have got 2 volume group. One is the split VG, that is actually the part of the VG1, but I had splitted this. Now I want to merge this. VG merge, very simple. Check what is happening, and then the original one, say the VG1 you wish to retain, and then split VG. It is merged. Volume, see the last line. Volume group split VG successfully merged into VG1. So if I give a PVS command, both are again the part of the VG1, and I have only one volume group. So splitting can be done, merging can be done. You can even rename a VG. Rename is very simple. I don't want this name VG1. I wanted a different name. So very simple, VG rename, and then say dev, say VG1, sorry, or I can just write like this, VG1, and say I say 1 VG. So now it is being changed to 1 VG rather than VG1, right? So you can change the name also. So you need to learn all these things, splitting, merging, checking all the things. Now once the VG is created, it's a time to create the LV. So very simple. There are a couple of methods in which the LV can be created, right? A very simple command is like, suppose right now I have approximately 1.5 GBs of space available here. I can specify the size in MBs. Say I give LV create. It is what you learned in your regular training programs. Say I say 600 MB, 600 M, right? And the name of the LV will be LV1, and it will be created from 1 VG. Hooah, job done. So if I give a LVS command, I have got LV name is LV1. It is available from 1 VG. Size is 600 MB. If you want more detail, -V, verbosity should be increased. Great. You can also increase the size, or you can also create a LV based on the percentage. So now if I give a VGS command, I have 820 MBs free. I want to create one more LV that should be occupying say 50% of the free space. So I can give a command LV create -L and say 50% of the VG, and the name will be, say I give the name LV2 and from 1 VG. Look, LV2 is created, and if it should be approximately 400 MB of size. LVS LV2. So the free was 820 MB, and I had specified here 50% of the VG. So it uses, so if I give the VGS now, no, it has taken more than that. Wow, that is great. Let us check it out. So I was just telling you that you can create the LV based on the size that I had just created of 600 MB, and then if the size is say 820 MB still free. Now I wish to create a LV that should occupy the whole space, right? So it's very simple. LV create small l and say 100% free, 100% free, and the name can be say LV3 from 1 VG. So it will create a LV named as LV3 which will occupy the whole 820 MB. So if I give a VGS here now, you can see nothing is free, and if I give a LVS now, I have got 820 MB of the LVM is there. There is another way of doing this, another way. You can specify the size in extents. Let me remove it for the lab. LV remove dev 1 VG LV3. I removed it. So again I have got 820 MB free. So first thing I can do is that I can use the VG display command, VG display, and then I can grep for the physical extents. So I say total PE free. So it says 355 PE is free. So when I get this value of 355, I can use this physical extent value to create a LV. Say LV create -L 355, and then from the one VG, and the name of the LV is say LV4. Let me check. It's not actually, because of the file system, it might be giving some issues. Okay, let me make it 205 from 1 VG, and the name is LV4. It's created. Now if I give a VGS here, see, it's 0 free. So you can check out the extent which is not coming actually the right value in my case, and then use that extent to create the VG. So that can be done, right? Now the next thing can be, I can use a particular PV to mention that I need my LV here. Let me remove it. LVS. I'm removing both the things, sorry, both the volume group, 1 VG LV1 and LV4. So right now I have got a VG that contains 3 physical volume, and I have got no LV. Now by default we know that the volume is linear. Linear means first the SDS7 will be used, then 8, and then 9. That is fine. But I can create a LV, logical volume, allocated from a specific PV in the VG. Because if I create the LV, that means, say if I create a LV here, LV create -L, say 400M, and the name is say LV1 from 1 VG. So it is created, right? And if I give the previous command here, you can see the size is occupied from the first one. See, there's a difference. 400 MB is taken from this because it's a linear LVM. I don't want this. I want that my LV should be taking space from SDA 9, not from the default SDA 7. That can be done. So first I remove this LV, remove dev 1 VG LV1. So now it is no LV and it's all blank. So what I do here, I give the command LV create -L 400M and name is say LV1 from VG1, and then specify on which physical volume you wish to be used for this LVM. It is actually 1 VG. Yeah. Now if I give a previous command, see, this is the magic. Now the LV1 is not created on dev SDA 7, it is created on SDA 9 as it has taken the chunk from here. So you can control, yes you can control that on which physical volume my LV is going to be placed or to be used. You can even specify the extents, that suppose I'm creating a LV of say 100 MB of say 100 extents. So I can control that, okay, 25 extents should be taken from SDA 7 and rest 75 extents should be taken from SDA 8. Even that can be done. Let me remove this. LV remove dev 1 VG LV1, fair enough. Now I don't have a LVM and my volume group is free and my physical volumes are totally free. Okay, now see here, it's a beautiful thing. LV create -L100, that means I'm trying to create a LV of 100 extents. The name will be again LV1 from 1 VG, but here I specify that it should be taking dev SDA 7 and should be using 25 extents from here, and then from dev SDA 9 it should be using say 50 to 125 extents, 50 to 125 extents. So total is 100, 25 from here and 75 from SDA 9. Okay, extends. There's a problem. I'll just check it out. Start extend 50 to and extend. Okay, let me change it from here. Let me make it a very small one, say of 50 extents. Because of the size of my physical volume, it is giving me error. Say from 0 to 25. So 25 extents will be taken from SDA 7 and 25 extents should be taken from SDA 9. Yeah. If I give a previous command here, see, 25 extents are taken from here and approximately 25 extents are taken from here. And if I give a LVS, it's 200, the size be in MBs, and if I give a verbosity here, see, and because I don't have the graphical tool available here, but I think it's very clearly visible from here. It is totally free and some 25 extents are taken from here and some 25 extents are taken from here. That is great. That is great. Now I can remove this again. LV remove dev 1 VG and LV1. We can also specify it in a different manner. So if I give a LVS, I don't have a LV, and again everything is free. I can give it in a different manner. LV create -L. I had given it for 50 chunks. Okay. So what I do here, I give a LV create -L 50 and the name is say LV1 from 1 VG. Now I am specifying it differently. From dev SDA, say SDA 7, it should be using 0 to 10 first, okay, say 20 first, and then should use from 40 onwards. What does that means? That means you won't be able to see this here. That means that on this HDS7 partition, the 50 extents were divided in such a manner that 20 extents were from the initial starting point, and then it has skipped 30 to 39 chunks and then taken 40 onwards to cover the whole 50. Got it? So in this manner you can specify the chunks. Might be because of some bad sector or something that you wish to use only specific locations, right? Okay, that means on HD7 it is not going to use from 21 to 39. That is the idea. From 21 to 239 it is not going to use. If you hadn't specified this, then it will take a linear from 0 to 50 in a single manner. Now it's a time to check how to resize the LVM. You know it very simple. If I give a LVS here it's a LVM. So LV reduce is the first command. You can specify the extents in which you wish to remove. Say I wish to remove only 2 logical extents, and then the name of your 1VG and LV1. It gives you a warning. So if I give a LVS here, see here 2 extents has been removed, so 192 now. You can also make it read only, a very beautiful thing. If I give a LV display here, by default the LV access is read write. I don't want this. I want the LVM to be read only. So I can very simply give the LV change command. The permissions is read only, dev 1VG LV1. So if I give the same command again, you can say very easily, see it is now read only. So that can be done to change the permissions of a LVM. Very important. Okay, next, how to grow LVM. We had learned how to create the LVM. We had learned how to choose a specific partitions. We have learned how to choose specific extents. We have learned how to change the permissions. Now reduce it, split the VG, merge the VGs. We have learned all those things. Now let us see how to grow the LVM. If I see the LVS, it is 192 MB and it is on a VG which is of size approximately 1.4 GB. So I can grow it in extents. I can grow it in say percentage. Say very simple command LV extend. Say I give -L, say 1G. That means whatever is the size, please make the size to 1 GB. Dev 1VG LV1. Look, whatever is the size, now the size will be changed to 1 GB. So LVS is 1 GB. So that means the absolute size. If you specify plus here, if you specify the plus here, say I give here plus 20 M. That means whatever is the size, add 20 MB more, 1.2 GB. Fair enough. Fair enough. So if I give a VGS here, perfect. You can also tell the LVM to occupy the whole available space. LV extend. Okay, let me show you the verbosity. -L, I give plus 100% free. So irrespective of the size, 1VG LV1, it will be occupying the whole space. So if I give a VGS here, I've got 0 space free, and the LV is of size of whole 1.39 GB. And by using the verbose option, it actually gives me what it is doing in the background. Now it's time to take the reports. How to take different reports, very important, not there in any standard training curriculum. Simple command like the PVS physical volume, or you want a more information, increase the verbosity. It gives you UUIDs, and other things. You can also use a separator here to make it much more human readable. So I give pvs hyphen hyphen separator equal to, so it gives you like this, hds7 is equal to 1 vg, rather than using this simple plain Jane. So the separator is equal to, size is this. You want it more aligned, use it hyphen hyphen aligned, much better. You can also like use the names also. Say I give here, say VGS. Now I give VGS and the option is, say I give plus PV name. Please show me the PV name also. So it gives you, look at the difference, the VGS here and the VGS here. It gives you the actual devices also, the PV names also, which PVs. Here it tells you that the VG1 it contains 3 PVs, but which PVs you don't know. You might need to give the PVS command separately to find out, but with this command you can have both the outputs in a single command. You can also use the free, say you give a PVS, it now you wish to know about the free, how much space is free. So option, so I give plus free, so it gives you how much space is free, the physical one, right? Okay, you give the PVS, it tells you the physical devices, those on the devices on which the PV create command has been run. Just do a reverse, hyphen a, the devices on which it is not run, not used as. In the same manner, if you give a LVS, it tells you a very plain Jane kind of output, but if you give a LVS hyphen hyphen segments, see, it tells you yes, it is a linear LVM, linear or striped or mirror, what kind of LVM it is. Merely giving LVM won't give you this detail. So segments, you want more information, please feel free to add hyphen v here, verbosity. So it's a linear LVM and it tells you all the things about it, right? That's great. I hope you're learning something new. And then a couple of more reports can be done, like suppose if you give a PVS command, it tells you how much is free, and you can also specify what parameters or what fields you want. Say I want the PV name, I want the PV size, and I want the PV free. So here it tells you how much is free on each physical volume, right? So you can also make it sort by the PV free. Say, and if you wish here, you can write here, say hyphen capital O PV free, means sort by the PV free value. Okay, I say PV size value because I don't have the free. Look here, 68 comes first and 76 comes later. Reverse the sorting, just add a minus here. Now 76 comes first and 68 comes at the last. One last thing in this video, when you give the PVS, it shows in MBs. You can also specify hyphen hyphen units M, show me in MB or show me in GB. So it tells you the size in GB. That makes, at least for personally, I found checking the LVS hyphen hyphen units G, I found it much more easy for my eyes rather than taking the output in MBs and then trying to calculate. So that is a lot more is there on LVMs. I can tell you this, a lot more, but I'm not going to finish in this video. I'll be telling you more about how to control the LVMs and learn more, much beyond your RHCE level. Learn beyond that. Believe me geeks, believe me friends, you will be asked questions based on these things, not on what is being specified in the text or the books. Learn beyond this, and that is why we constantly tries to give you more or give you the wow in our videos and the trainings. Thank you for listening, thank you for seeing, thank you for coming back, and this is Alok Srivastava saying bye and take care, and I'll be seeing you soon. Bye. I'm stopping the video now.